let's begin our session two. So here I will eventually take you through the fundamentals of data analysis. So yes, when I speak about analysis, I talk about what are the types of data, what is the pre-processing, data cleaning, and we'll also talk about measures of central tendency and dispersion. And in the end, we will stick to our Excel exercise that I spoke about. So I will teach you pivot tables, pivot charts for data analysis. Now, here, I think you will go through, you will find me putting in jargons which may not be very familiar to you guys. But trust me, these are very fairly easy, and these are the most basic topics when it comes to data, which is very, very important. So that, going forward, you will learn which sort of analysis you need for which sort of data. So this becomes really important. So first and the foremost thing, the data types are basically divided into two types. So one is the qualitative, the other one is the quantitative. So as the names itself suggests, your qualitative data is mainly categorical. So I'll get into the details what categorical is, and a quantitative. So what do you mean by quantity? The numbers. So your quantitative data is basically is very much the numerical forms. I'll tell you what they are. So again, your qualitative data. So this bucket actually describes the data that fits into multiple categories. So what I mean by categories is, for example, maybe if you look at a person's gender, a person's hometown, maybe the color of your hair. So all these are multiple categories. So these cannot be measured. So you cannot give in numerical values for a person's gender or a person's hometown. So, but there are a couple of categorical data such as your birth date, your postal address for your home address, your school postcode. But even though these are numerical in nature, but they do not have any numerical meaning for it. So this is what qualitative or categorical data means. And now this again is broken down into two types: ordinal and nominal. So getting into ordinal data, so this data is type of data that actually follows a natural order. So what I mean by that is, number one, it can be ranked, it can be ordered, it can be ranked. It cannot be measured. One thing that you cannot do with ordinal type of data is you cannot measure it. I'll give you examples of how these actually work. It also does not have a meaningful zero. So what I mean by meaningful zero is, let's say you talk about the sizes of shirts. So you have your XS, you have S for small, XS extra small, medium for large, M for medium, L for large, XL for extra large. So even though these can be ordered, they can also be ranked. So your XS takes rank 1, S takes rank 2, M takes rank 3, so on and so forth. But they are not equidistant. So what I mean by that is, you cannot say your XL minus L gives you medium. You cannot do A minus B equal to C here. So this is the type of ordinal data. So this variable, is mostly found in surveys or all your questionnaires. So these are the type of ordinal data, and you mainly use your bar charts for this type of data. And when it comes to your nominal data, so, yes, before getting into that, I would also want to touch upon the mathematical operations that you can actually use on your ordinal data here. So, one thing that they can be grouped into multiple categories. They can also have rank, such as, you can use your operational mathematical operations, such as, you can say your S is less than M. You can use a less than sign. You can use a greater than sign. Your L is less than your XL, or maybe your L is greater than your S, so things like this. And when it comes to operations, you can usually perform frequencies or percentages or proportions, or just finding the central point of the data here. But you cannot perform addition, multiplication, subtraction, any of this on your ordinal data. Now coming to nominal data, nominal data is again something which cannot be measured. It cannot be ordered. So your ordinal data can be ordered, your nominal data cannot be ordered. It also doesn't have a meaningful zero. I mean, let's say you take up the example of hair color, your black hair or your brown hair. You cannot say zero is black hair, one is brown hair, two is red hair. You cannot do that. And also, it cannot be equidistant. Like I said, you cannot compare a person with black hair with a person with red hair and you give them points. This doesn't happen here. Coming to mathematical operations on nominal data, so these can be grouped into categories because it falls under qualitative data. And one thing is that these cannot be ranked and these cannot be sorted here. Okay, so a couple of examples. So this is how nominal data is different from ordinal. So couple of examples is your nationality, your gender, your hair color, my previous example. So things like this. So this was your ordinal and your nominal data. Now coming to quantitative. So what I mean by quantitative is it usually talks about numbers and can be measured. And this again can be divided into two types. One is your continuous, the other one is your discrete. So when I talk about discrete data here, which can be counted. So what I mean by discrete is it can be counted, but it cannot be divided. What I mean by continuous data is it can be measured and can be divided. So what I mean by that is getting into continuous data here, it takes fixed finite values between two data points. That is, let's say you take up weight of students in a class. So it can be anything between 30 kgs and 40 kgs. And it can also be put into smaller parts. So let's say you want to measure the range. So it will stand between 45 and 45.5 kg, things like that. These are usually connected elements and can change as per time. That is your continuous data. And usually histograms and scatter plots are the ones that are used for continuous data here. Okay, so and examples can be your weight of a person, time or height of a person. So these are usually not whole numbers here. So these can also belong to decimal points. But coming to your discrete data, so these take fixed finite values in a specific range. That is, if, for example, if let's say class A has 20 students, class B has 30 students. So these are definite. They do not take any decimal values. And you can also not break it down into smaller parts. So let's say you cannot say class A has 30.5 students. Zero point 0.5 does not make any sense here, correct? So these are, that is the reason you cannot break them into smaller parts. These can be counted but not measured. And it has to be a whole number. So your shoe size, the number of tires in a vehicle, all these falls under your discrete data. Example, cats, like what I've given here. Distance can be continuous in nature, 1 kilometer, 1.2, 1.4 kilometer, and so on and so forth. So these are the data types here. You will need to learn what sort of data you are actually dealing with so that in order to apply the proper analysis to be made to achieve any solution here. Now coming to data pre-processing. So like I said, whatever raw data that you get is not ready for consumption. So there are multiple things that you need to do in order to process the data so that you need to make it ready for presentation or ready for visualization, ready to bring in insights for the same. And couple of them are your data cleaning. So usually it starts with data cleaning procedure. So what I mean by data cleaning is, you look at garbage values, you look at your outliers, you remove or you correct any errors, any inconsistencies in data. Example for inconsistencies means maybe the dates can be in multiple formats here. You can have your DD, YYY, or maybe DD, YYY. There can be multiple formats. You need to end up bringing them into one single format here. Integration is nothing but combining data from multiple sources into a unified data set. So like I said, there can never be one source of data. There will always be multiple sources of data, and you need to know on how you can connect them with each other so that the connections that you make are actually proper. If you are looking at one to many connection or many to many connection, things like that. And data transformation, this is mainly your deconverting data into a suitable format for analysis. So it can be your normalization, your scaling, things like that. So when it comes to data reduction, so data reduction, what we do here is we actually reduce the data size. Again, when we are reducing it, we need to take into account of many things so that we do not leave out on important data here. So we actually look at the data set, which is very, very important, the fields, the variables that are very important, and then we go ahead. And data discretization and data normalization, I think um, these are not that important. So what I mean by discretization, normalization, it basically is they are a couple of other standardization formats which are very much important. Important. So what I basically mean is you cannot compare apple to oranges here. So even if you do your pre-post analysis or your let's say you want to run experiments on any particular data to achieve any solution. So in order to make sure you need to make sure that both your data sets are actually common. They're one and the same, but you are comparing them with two different variables. So things like that. I'll just go ahead. So now coming to when you talk about data mining, so I think data mining would be a pretty important step. And there are three most important things here which play a huge role. So data cleaning, like I said earlier, there can be missing data or there can be noisy data. So missing data is maybe there are few missing values which you need to put in or few values which you need to replace. For example, if you come across an error in Excel, you get that hash n/a that variable. You need to maybe replace them. When it comes to noisy data binning. So what I mean by binning method is your entire data can be actually clustered into smaller segments. So let's say if you look at your e-commerce data for a month, the orders data would be pretty huge. So what would you do? Maybe you can, divide and take aggregations over your product level or over your category level, or you can divide all your prices into multiple buckets. So let's say you take 0 to 500 rupees, you group all your data into one bucket. Your 501 to maybe 2000 rupees, you group all your transaction into one bucket. So this is binning. Coming to regression here can be made smooth. Data can actually be made smooth by fitting it into a regression function. So this can either be linear or multiple. This I will get into detail pretty later on. Clustering again is what I said. Dividing your entire data into multiple groups is called clustering for easy access. Now coming to data transformation. Here, in order to, this is the step that is in order to transform the data into appropriate forms, which is also suitable for your mining purposes. And these are the few concepts here which are very important. So coming to normalization, so like I said, it is in order to scale the data values in a maybe specified range, or if you want to compare two data set, you normalize both of them, bring it into one unit. So see, just to give you a small example, you cannot compare centimeters to feet. You cannot do that. You cannot say 10 centimeters is greater than 1 feet. So you need to normalize both the units on both the sides and then compare them. So this is what normalization is. Your attribute selection. Here, new attributes which are constructed from the given set of data or your attributes, which help in the mining process. So, what I mean by new attributes which are constructed, maybe you want to fetch in SLA. SLA is just maybe the difference between two dates. So things like this, or maybe age even, so things like this. So your discretization, this is done to replace all the raw values of a numeric attribute by interval levels or by conceptual levels here. Again, there's one metric which is called as concept hierarchy generation. This is very, very important. So here, basically, what happens is when your attributes are converted from either lower level to higher level or higher level to lower level, you need to see how the hierarchy actually works. So what I mean by hierarchy is one lame example which I can take is maybe your entire address in a database system can be divided into multiple smaller attributes, like you have your city, you have your country, you have your postal codes here. So when you drill down, you move from country to city. So when you drill up, you move from city to country. Okay, that connection is what I'm talking about. Coming to data reduction, all your feature selection, feature extraction, I think both these are pretty much similar. The only thing that you need to make sure is whatever important data set, even though you reduce the size of the data set, you make sure that you preserve the important information, you preserve the important columns that you need. So this is basically feature selection and feature extraction. Coming to sampling, clustering, I think these two are pretty similar. So what I mean by this is again involves selecting a subset of data points from an entire data set, grouping them among similar data sets into smaller buckets, into smaller groups, so that the processing becomes pretty easy, and you need not deal with a large set of data. Compression usually involves in changing the reducing the size of a data set for any this can be for your either storage or your transmission purposes. So these were some of the pre-processing steps in data mining. Let's move on. Now coming to descriptive statistics. There are a few measures of central tendency and dispersion. Can anybody tell me what is the meaning of dispersion? I mean, basic knowledge of dispersion. I mean, what does dispersion mean in English?
The things which are spread over a wide area.
Yes, yes, exactly. So dispersion is nothing but how far or how far or how are your data points actually scattered from some given point, which is usually the midpoint. Before getting into all your measures here, which is mean, median, mode, range, standard deviation, variance, I think many of you would have gone through what these variables are already. I'm going to just explain why variability matters. Why variability matters. I think I have a small example to show that. Just give me 1 second. This is not the one. This is not the one. Yeah. Okay. I'm just going to um, increase the size. Now let's say you have two data sets here. So one data set, if you can see, you have 5 elements here, some random numbers. The other data set, again, a set of 5 random numbers. So average, if you take it, so what is average? It is nothing but the sum of all your elements in an array divided by the number of items here. So here it's 87. Here again is 87, the average of the data set. But if you actually plot these data points on a graph, so this is how it actually looks. So if you can see here, all the data points are fairly closely placed next to one another. But if you look at data set number two, the data points are actually scattered. And now the reason why this becomes fairly important is when you want to make decisions. So let's look at these two graphs here. You have your data set B and your data set A. Okay, I had to exchange both these, but it's okay. I've named them. My B is my first data set, A is my second data set. So if you look at the difference between A and B here, if you look at A, the data points are very close to each other and they're very consistent, if you say. But if you look at dataset B, it is broken down at a couple of points and it is not consistent. Like if you see here, if you look at the fourth point, there is no data at all. And if you look at your 3 and your 14, that is for starting and the ending points, they're not pretty same. But if you look at your data set A, this looks like a good bell curve, which is so actually know that whatever data set is consisted in A is actually consistent, and this would prove very useful to me. So I would go ahead with my data set A here. So this is the reason why variability is very important to actually know how your data points are situated in the graphs. So now, if you can see here, there were a couple of there were a couple of variables here, which I will take you through: your mean, median, mode, range, and standard deviation and variance. So now coming back to the file here. So, first and the foremost thing is the range. I think range is the most simplest forms of measures. So, what I mean by range is if you take up your highest value and your lowest value, the difference between them is what gives you the range. So if you look at two of my data sets here, maybe first look at these. So here my highest variable is my 95 and the lowest element is 80. So my 95 minus 80 gives me 15. So 15 is the range for this data set. But if you look at this data set, 125 is the range. But if you look at both these graphs above that I've pasted, even though the range is one and the same, which is 120, you know that the data is pretty consistent in your set one, unlike your set two. So if you see here, one person has scored 30 marks, other person has scored 40 marks. There are many people who have scored 50 marks, but there are so many people who have not even scored 70, 80, 90, 100. It means that the distribution it has not been uniform across. So now coming to standard deviation, I'll come to standard deviation pretty later on. Let's just go through what mean, mode, and median are. So my mean is nothing but the average of all the data points. That is, you sum up all the units in your data set and divide it by the number of elements that appear in your data set. So for this particular example, my mean or my average is 23.7. Now, coming to median. So, median, the word itself suggests. So, what I mean by median is the midpoint. And there are two types of methods that you can use to actually find out your midpoint. One, when you have an odd number of items, usually it's the middle point after you have sorted your entire data or entire array. So, once you have sorted, remember sorting is very important when you work with median and mode. So, after you've sorted, the midpoint becomes your median for an odd number of items. But when it comes to an even number of items, once you have sorted the data, you just take the average of the middle 2 points here. So after I've sorted my data from my lowest to highest here, from 3 to 95, these two would 7 and 10 would be my midpoint. So 8.5 would become my median here, which is again the average of these 2 points. Now coming to mode. So what I mean by mode is nothing but the frequency. That is, see, the mode here for this particular data set would be 7. The reason being 7 appears the highest number of times in the data set. So this is nothing but the mode. So these are pretty basic concepts which are very much necessary in order for you to understand your standard deviation. Now, let me take you through what a standard deviation is. So, like we all know, deviation is nothing but the distribution of data from its middle point here. So now if you look at the graph here, this is called a normal distribution. It is also called a bell-shaped chart. So here, the way you read it is 0 would be my midpoint. Okay. And from 0 to 1, with a deviation of 1, you will land at 1. With a deviation of 2, you will land at 2. Now, from 0 with a deviation, if you go lower, if you go backwards, that is from 0 with one deviation behind backwards, you will land at -1. Similarly, with two deviation points, you will land at -2. And if you look at the data that has been distributed over here, you can actually see that. So this is how you read it. You can actually see that your 99% of data appears between this particular bracket, that is between your -3 and your 3. It means that most of my data points usually, most of the 99% of my data points fall under this bucket here. And as you move up the curve, you can actually see this number actually reduces in a normal shape distribution. That is, your 95% of data would fall between -2 and +2. And even if you go further up, you will find that 68% of your data falls between your -1 and 1. So one easy example I will give for understanding here. Let's say you talk about IQ scores. So IQ, intelligence scores for any person. So let's say my population mean is 100. That is my average IQ for any for across a population of certain number of people is 100, and my population variance is 15. So in this case, my population variance was 1. So that is the reason if you moved 1 on the right hand side, it will increase by 1. If you moved on the left hand side, it would increase by -1. Now coming to my IQ example over here. Now this is my data set. If you can see here, sorry. So my data set consists of a number of a number of IQ. So all these are my IQ measures. You can imagine these to be your x-axis here. So now let's say 68%. So most of my people fall under the 68% bucket, which usually where the IQ usually stands between 85 and 115. My 95 percentage of my population falls between 70 and 130. And coming to my 99 percentage, usually most of the 99 percentage of my data points falls between my 55 and 145. It means that the way you will read it is, so if at all your IQ is, let's say, 146, which falls after this curve, it means it is very rare. Not many people have it. But if you look at the 106, so 106 falls somewhere between here, closer to my 100, right? Which is also closer to my mean in this case. So it means that your IQ is fairly good. I mean, because that is also being the one reason also being many people's IQ falls in this particular bucket. So that is the reason. So this was your mean, median, and mode. So with the given amount of time, I'll quickly jump to your next. I'll quickly jump to your next exercise, which is Excel data visualization techniques. I'll teach you what pivot tables, pivot charts are for data analysis. So yes, I have a small exercise built for you guys. Quickly open it. Yep. So yes, as you can see here, this entire data set is the orders information for a basic supermarket which I have taken here, and there are multiple columns here which have which define various fields. So you have your customer ID, your customer name, what was the order priority here, the mode of shipment, the customer segment. So your customer segments are, it can be corporate or home office, small businesses, what was the product category that was bought, subcategory, container, country. You have your region, you have your city, postal codes, order date, month of the order date. This is your profit, your sales, and your order ID here. So imagine this to be one of your tables, and other information is placed in other tables here. So here you have your order ID, you have your statuses. Here you will only find all those order IDs that were returned. Now, coming to users, so users, you have your managers who have been appointed for those particular regions, your central, east, west, and south. Now, let's get into the data here. So, before getting it, I have a couple of questions which I've already added down here. So, it will become easier for me to show you how how pivots work, how charts work, and how fairly easy it is to use Excel here. I'll get into this later on. So first, let's join both these tables here. So you have your returns, you have your users table, and you have your orders table. So from your returns table, you can actually get your. I have separate exercises for you guys as well. Now, since we have really less time, I'll just go through. I'll just sum up how you can use pivots and charts here. Then later we can get into your exercises. Sure. Are you guys with me so far? Please let me know if I'm going really fast.
Yeah, yeah, we are there. Man.
Okay, sure. If I'm going really fast, do let me know. Okay. So
Yeah,
yeah, thank you. So we have a returns table here. So one common thing that I can use to join both my returns table and my orders table is my order ID. So always remember whenever you have to join two tables, you will need to make sure that there is one unique field in both your tables, which will not give you duplicates when joined, which is very unique for both the tables also. And even the data types of these two cells are pretty much same. So over here, I can actually use my order ID to join with my orders table. My order ID is present here as well. And when it comes to my users table, I think I can use my region here. So you can actually see. So there's one particular manager for one particular region. So this is again fine. So let's get all my returns. I will name this as my returns field here. and later I will bring in my managers. So now for returns field, I will, so yes. So there's one small function which is called as VLOOKUP. I think most of you guys would have already used VLOOKUPs in Excel examples. Let's still go ahead. So VLOOKUP is a function which where we can actually map or bring in values from another data set to my particular data set based on a common column here. So what Excel actually does is it takes in my lookup value, it goes through the other data set, it skims through it. Wherever it finds the matching value, it fetches that data to me. So this is my Excel equation to actually use VLOOKUP. So I'm going to VLOOKUP my what is the value that I need to match here. It's my order ID. So this would be my um, first field here. I'm going to give a comma. Now returns here you'll need to actually select what is the range of data that you want to look through. So since here I have just two columns, I'm going to select both my column A and column B. So this would become my range. Next comes the number of the or the key. You can take it as a key. It is just the number of the field that you want to fetch. So since here I want to match on my order ID, but I want to fetch my status. So I will give number one to my order ID, number two for my status. So I will be fetching my status. So that is the reason this should be two here. So this number is just nothing but the serial numbers. You can just go on giving serial numbers in the order of the columns that actually exist. So then my last attribute is something called zero. Zero is nothing but I use it for an exact match or an approximate match. You can either give zero or one based on your requirement. So now, since I want the exact match, I'm going to give in zero, and I have the first formula applied for first column here. I think I'm just going to drag the formula apply to the entire column. I'm going to remove formulas here. So what I've done here is after giving my formula here, I've just copied the entire column. So after copying, I have removed, there's something called paste specials here, paste values. There are common keyboard keys which you can use, but for explaining purposes, I'm using the functions that you see on my screen. So here, after you bring in your returns field, there can only be two values here. One, it can be either return, this return keyword is already present, or you will get hash NA. If your lookup value is not present, Excel will give you hash NA, which also means that the product was not returned. So for easy purposes, let's clean our data. So this is one classic example of garbage data, which we do not want. People would not understand it also. So I'm just going to name it as not returned. So if you put in your filters now, you can see returned and not returned. See, this would become easier for understanding. Now anybody can read it. Let's bring in our managers as well, because manager data is very much important for a couple of our questions here. So if you can remember here, users, your managers, and it had only one common column, which is called as region here. So I will be looking up based on our regions here. So let's search for our region. Region is here. This would be my search value. Now coming to this would be my region. I mean, this would be my search region. Again, here I need to fetch my second attribute here, which is the manager name. Oh, sorry, one second now. We look up my region, my lookup range. This would be my lookup range. I need my second attribute, which is manager name. So I'm going to give in 2 and then comes 0. Similarly, I am going to follow the same procedure here as well. Let's say, why am I getting only two users? Ideally, there are four managers. Let me just repeat what I did, but this time with a wider range. this works. Okay, I think there was an error with the range earlier. No issues. So we bought all our four managers' names for our four regions, Chris, Erin, Sam, William, accordingly. Okay, this is good to go. Let's look at our first question here. Before that, just my suggestion here would be to just go through your data, see if all your data points are right. What I mean by that is, if you look at customer ID, make sure that you only have your integers here. You do not have your decimal points because it wouldn't make any sense. If you have any dates, make sure that they belong to the same format because different formats would again mess up your visualizations for any dates that occur. Then yes. See again, quantity order. This cannot be a decimal value. So we will make uh, such smaller data sets data checks just to make sure that our data is sane and correct. So first, so our first question here would be, I'm just going to take you through a couple of examples, which will just give you a basic example of how you can actually use Excel. Here, what I've done is my first question would be region-wise sales or my orders. So what I would do is this is my base data set. So in order to bring or apply a pivot for this, you just have to select your entire data set. You can either do by dragging or you can use your Control Shift keys and come to your tab on the top. You just give in your pivot table. So now pivot table, you can either choose to apply it in the same data set, in the same worksheet, or you can just or you can just use the same worksheet or any different worksheet. That is fine. So for now, I think I will go according to a newer worksheet. One second. Insert new worksheet. So this is my new worksheet here. So what I have earlier done is I've already pasted the pivot here. So it will become easier for me to just sort of start off with the questions here. So as you can see, once you have applied all the pivots, now all your data points are present here. Uh, one thing that we one thing that we should do is you need to go back and refresh this database, refresh this pivot. The reason being, I have already, when I had put when I had put these pivots, these functions were not there. I mean, these additional keys that we performed. One is the returns field and the manager. Now let's see if these are already here. See, like I said, this is not there. So what you would do in this case is you would just go back to something called pivot table analyze. Click here. You will need to change the data source for these. So now in this data source, I am telling my entire Excel that, hey, Excel, I have changed the data source. So I want you to take in the new fields, which I created as well. And then after this, just refresh your pivot here. So now you will find your new new column fields that were created. One is your returns field, the other one is your manager. So yes, so let's just start off. So this I will need region-wise sales and orders. So one thing, let me remove order priority from here. Let me bring in my regions. See, there's a column called regions here. And now these four buckets that you see here on your right-hand side below are your rows, your columns, your values, and your filters. If at all if at all you want to apply any filters for your data. Got it. So let's take about, so they want region-wise sales, right? So first and the foremost thing, I'm going to bring in my regions. So now see, the way you represent data is actually up to you. You can put it in your rows or you can put it in your columns. It doesn't usually matter. For now, what I am going to do is I'm going to maybe represent month-on-month sales or month-on-month orders for better understanding or just to see how my trend is. So I'm going to search my month here. I'm going to drag and drop my month in my columns column here. So what you can see here is this is all my regions here, and these are all the months here, 1 to 6. That is from Jan to June. We only have so much data over here. And later, your sales can be defined into two things. One, you can either bring in sales, or the other one, you can either bring in your number of orders that you have received. So For this example, I think I'm going to show both, but for now, let's stick to my order ID. And now see, if you can see here, Excel automatically picks sum of order ID, which doesn't make any sense. We do not want to add up all our order IDs. It wouldn't be right. So what I'm going to do is, if you can just click on this arrow key here, click on your value field settings, you can actually set the type of aggregation that you want to do on your values here. So since I brought in my order ID, I don't want to do a sum, although Excel takes sum by default. I'm going to stick to my count of order IDs. So when you click on OK, choose this. If you can see, there are multiple other variables as well. You can bring in your standard deviation, your variance, your count, min, max, average. For now, I'm just going to stick to count for our business requirement. So if you can see, this is a normal chart, and this is a normal table which gives me information of month on month sales or month on month orders that all these four regions received across the months. So in order, see, if you look at this, maybe it would be difficult for anyone to notice at the first glance. So what I'm going to do is I'm going to select this entire data and put it in the form of a chart. So you come here, but Excel is pretty smart. So, it also recommends charts for you, but you can also choose whichever charts you want. I think I'm going to go with a simple bar graph here. You can place it anywhere. You can also edit this particular graph itself. So so if you can see here, these are all my regions here, and these are all the number of order IDs that I have received over the months. And these are my 6 months here. So for easier understanding, what I'm going to do is I'm just going to pick my first month. So see, this would give you a better understanding. This would become very much easy for reading. So now anybody can tell my central region is performing better, has performed better in the last 1 month. Sorry, in the last January month with the orders ranging more than 100 here. So that is the reason I think it's fairly important for anyone to visualize your data fields. So let's go ahead with the comparison of 2 months here. Over here, you can actually see your East performed really bad in the third month, but it had performed really good in your first month. So, you can also divide it based on your regions as well. You can give in filters here. So this is how easy it is to put up charts, to put up visualizations for easy readability as well. Now, there are a couple of other questions as well. What I'm going to do is I'm going to show couple other examples. Maybe then later give. I also have questions here for a small exercise which you guys can take up.